Syllabus for Geophysics. There will be 3 sections in the Geophysics GP test paper, namely Geology, Mathematics and Physics, each with a weightage of 50% marks. A candidate has to attempt any 2 sections. The syllabus for the category Mathematics and Physics sections of the Geophysics GP test papers are given below. Geology section: the planet Earth, origin of the solar system and the Earth, geosphere and the composition of the Earth, shape and size of the Earth, Earth-Moon system, formation of continuates of ozone, dating the rocks and age of the Earth, energy in the Earth system, volcanism and volcanic landforms, interior of Earth, earthquakes and seismic waves, Earth's mechanism and gravity isodesy, elements of plate tectonics, orgogenesis, germophology, weathering and erosion, transpiration and deposition due to wind, ice, river, sea and resulting landforms, structurally controlled landforms, structural geology, concept of stratum, contour, outcrop patterns, maps and cross sections, deep and strike, classification and origin of folds, joints, foliation and lineation and confederates, shear zones, mineralogy, symmetry and forms in common crystal classes, physical properties of minerals, isomerism and polymerism, classification of minerals, structure of silicates, mineralogy of common rock forming minerals, mode of occurrence of minerals in rock, stratigraphy, principle of stratigraphy, geological timescale, ages of major stratigraphic units of India. Petrology, definition and classification of rocks, igneous rock forms of igneous bodies, crystallization form magma, classification and association of igneous rocks, principles of stratigraphy, sedimentary rocks classification, texture and structure, metamorphic rocks classification, phases, texture and structure, economic geology, physical properties of common or minerals, general process of formation of mineral deposits, mode of occurrence of important metallic and non-metallic deposits in India, gold, petroleum and groundwater occurrence in India. Mathematics section: sequence, series and differential calculus, sequence of real numbers, convergent sequence and series, mean value theorem, Taylor's theorem, maxima and minima, functions of several variables, integral calculus, fundamental theorem of calculus, integration, double and triple integration, surface area and volumes, differential equations, linear or non-linear, ODE, existence and uniqueness without proof, linear differential equations of second order with constant coefficients, vector calculus, gradient, divergence, curl, Laplacian, Green's, Stokes and gases theorems and their application. Linear algebra, system of linear equations, matrix, rank, determinant, inverse, eigenvalues and eigenvectors, dimension, linear transformations. Real analysis, open and closed sets and limit points in OR and completeness in OR, uniform continuity, power series, uniform convergence. Probability, probability space, conditional probability, independence, Bayes theorem, univariate and bivariate random variables, moment generating and characteristics functions, binomial, Poisson and normal distributions. Statistics, sampling distributions of sample mean and variation, exact sampling distribution, normal population, simple and composite hypothesis, best critical region of your test, Newman-Pearson theorem, likelihood, radio testing and its application to normal population, comparison of normal populations, large sample theory of test of hypothesis, approximate test on the parameter of a binomial population, comparison of two binomial populations, complex analysis, analytical functions, harmonic functions, Cauchy's theorem, Cauchy's integral formula, Taylor and Laurent expansion, bolts and residues. Numerical analysis, difference table, symbolic operators, difference of a factorial, representation of a polynomial by factorials, forward, backward and central differential. Approximation formula. Simpson's on third rule and the error in it. Gauss-Seidel method and method of elimination for numerical solution of a system of linear equations. Iteration method and its convergence. Gradient and Newton-Raphson method and their convergence. Physics section. Mechanics and general properties of matter. Newton's law of motion and application. Kepler's law, gravitational law and field. Conservative and non-conservative forces. System of particles. Center of mass, equation of motion of the CM. Conservation of linear and angular momentum. Conservation of energy. Elastic and inelastic collisions. Rigid body motion. Flexed axis rotations. Rotation and translation. Moments of interior and products of interior. Principal moments and axes. Elasticity. Hooke's law and elastic constants of isotropic solid. Stress energy. Kinematics of moving fluids. Equation of continuity. Euler's equation. Bernoulli's theorem. Viscous fluids. Surface tension and surface energy capillarity. Oscillation waves and optics. Differential equations for simple harmonic oscillator and its general solution. Superposition of two or more simple harmonic oscillators. List-Jover's figures. Damped and forced oscillators. Resonance. Wave equation. Traveling and standing waves in one dimension. Energy density and energy transmission in waves. Group velocity and base velocity. Sound waves in media. Doppler effect. Fermat's principle. General theory of image formation. Thick lens, thin lens and lens combinations. Interference of light. Optical path retardation. Frowner diffraction. Reline scrutation and resolving power. Diffraction gratings. Polarization. Linear, circular and elliptic polarization. Double refraction and optical rotation. Electricity and mechanism. Coulomb's law, Gauss's law, concept of potential, field and boundary conditions. Solutions of Laplace's equation for simple gases. Conductors, capacitors, dielectrics, dielectric polarization, volume and surface charges. Electrostatic energy, magnetic susceptibility, Bohr magnet, its magnetic field and its elements. Boyd-Savitt law, Ampere's law, Lenz's law. Faraday's law of electromagnetic induction. Self and mutual induction. Alternating currents, simple DC and AC circuits with or L and C components. Displacement current, Maxwell's equations and plane electromagnetic waves. Lorentz force and motion of charge, particles, electric and magnetic fields. Kinetic theory, thermodynamics. Elements of kinetic theory of gases. Velocity distribution and equilibration of energy. Specific heat of mono, di and triatomic gases. Ideal gas when there wells gas and equation of state. Mean free both. Laws of thermodynamics. Zeroth law and concept of thermal equilibrium. First law of thermodynamics and its consequence. Isothermal and adiabatic process. Reversible, irreversible and quadratic process. Second law of thermodynamics, Carnot cycle. Modern physics, black body radiation, photoelectric effect, Bohr's atomic model, X-rays, wave particle duality. Uncertainty principle, Pauli exclusion principle, structure of atomic nucleus, mass and binding energy, radioactivity and its applications. Laws of radioactive decay and half-life, fission and fusion. Solid state physics, D-waves and electronics. Crystal structure, Brouwer's lattice and basis. Miller indicates X-ray diffraction and Brock's law. Origin of energy bonds. Concept of holes. Intrinsic and extrinsic semiconductors. B-N junctions, transistors. Amplifier circuits with transistors.